Hello, algebra students. This lesson is on solving quadratic equations by factoring. Now, last chapter you guys probably thought, why do we factor? Well, one of the benefits of factoring is it helps us solve these quadratic equations. Now, what makes a quadratic equation? Well, if you have a degree 2 polynomial, such as ax squared plus bx plus c, you have this polynomial set equal to some number. Most of the time it'll be equal to 0. Okay, if you ever had this x squared term in an equation, you know you have a quadratic. And it also tells you one thing: you can have up to 2 solutions for this equation. Okay, now when we solve quadratics by factoring, one thing we use is what we call the zero product property. Okay, and that is basically something times 0 will always equal 0. So how do we use it when we solve these quadratics by factoring? Well, if I have x plus 3 times x minus 2 equals 0, there are 2 values of x that would make this equation true. Well, if I can find the value of x that makes this binomial equal 0, alright, we know that value is negative 3. So if x is negative 3, we know negative 3 plus 3 is equal to 0. And if this is 0, 0 times negative 5 gives you 0. True statement, right? Well, what happens if we change it up? Say we make this quantity equal 0. Well, what value of x would make that equal 0? Well, if x is 2, 2 minus 2 equals 0. So now if this is 0, 0 times 5 is 0. That makes it true. So these end up being the solutions. Well, in order to get to this form, we have to be able to factor. So how do we solve these quadratic equations by factoring? Well, it's basically a 3-step process. Okay, the first one is to set the quadratic equal to 0. Once we set the quadratic equal to 0, we factor the quadratic. Now, once we factor, we'll have something like x plus b times x plus c equals 0. So, to get the solutions, what we do is we basically set each factor equal to 0 and solve for the variable. Okay, let's do a couple of examples here. So, in number 1, if you look at that quadratic's already set equal to 0. So step 1, we don't even have to worry about. So our next step is to factor it. Remember, this is an easy AC, or to factor it, all we have to do is find the numbers that multiply to give us 24 and add up to 10. And we know what makes this happy is 6 and 4. So once we factor this, we get x plus 6 times x plus 4 equals 0. Well, now that we have it factored, I'm going to take each of these factors and set them equal to 0. And when I solve for the variables, I get x equals negative 6. That is one solution. And when I subtract 4, I get x equals negative 4, and that's my other solution. Okay? So if factoring is the part that's stumping you, I would probably go back to some of the videos on how to factor from the last unit, because it is very important for this unit. Now when I look at the second one, again, this one's already set equal to 0 also. But there's only 2 terms in this one. If you remember when we factor, right, our first step is to look for a greatest common factor. Well, is there a GCF for this problem? Well, 2 and 8 have a common factor of 2. X squared and x, they both have an x, so I can pull out at least 1. And if I divide each of these by 2x, I have x plus 4 left over. Oh, can this be factored any further? No. So what we do is we take this factor, set it equal to 0, and I take this factor and set it equal to 0. And if I solve each of these equations for x, right, if I divide by 2, x equals 0. That's one answer. If I subtract 4, x equals negative 4. That's my other answer. If I were to plug these values of x back in, independently to the original equation. These are the values of the variables that would make the equation true. Okay? Number 3. When you look at number 3, is this quadratic set equal to 0? No. Alright, so what do I do here? Well, to get this equal to 0, I have to get rid of this 5. How do I get rid of it? I subtract it. The like term I can line it under is negative 25. So here I have x squared minus 13x minus 30 now equals 0. Now I can look to factor this. Well, I don't have a number in front of x squared, so I know it's like an easy AC method, or I can find the numbers that multiply to give me 30 and add up to give me that middle term, which is negative 13. And this here would be negative 15 times 2. So I go ahead and I factor this. X minus 15 times x plus 2 equals 0. Am I done? No. Once I factor it, now I have to set each of these factors equal to 0. When I solve here, I get x equals positive 15. That's one answer. And x equals negative 2. And that problem is done. Okay, so again, set it equal to 0, factor it, and then basically go ahead and set each factor equal to 0 and solve for x. So this next one, when I go to factor this, I notice I gotta find the numbers right away because there's no number in front of x squared. So again, it's an easy AC problem. Find the numbers that multiply to give me 64 and add up to negative 16. What numbers make that happen? Negative 8 times negative 8. So when I factor this, I get x minus 8 times x minus 8 equals 0. Well, think about this. If I pull these both these factors out and set them equal to 0, when I solve this, I get x equals 8. When I solve this, I get x equals 8. How many solutions does this quadratic truly have? Well, in this case, since these solutions repeat, we really only have to write one final answer. The only solution to this one is x equals 8. Okay? Hopefully it's easy to follow along with. So the last example, 3x squared plus 7x plus 2 equals 0. Is this quadratic already set equal to 0? Yes. Now I have to worry about factoring this polynomial. Okay? Well, if there's a number in front of x squared, what method do I have to use? I have to use the AC method. So if I multiply A and C together, 3 times 2 is going to give me 6. So I have to find numbers that multiply to give me 6 and add up to that middle term, 7. Okay, what numbers make that happen? 6 times 1. So if you remember, this is where I split that middle term. Bring down my first term. Split this middle term such as plus 6x plus x. Bring down that last term. Now I group. So, what's the greatest common factor here? Largest number that goes into 3 and 6 is 3. If I have x squared and x, I can pull one x out. What do I have left here? X plus 2. If I look at my second binomial, is there a GCF between these two terms? No. But if there isn't a GCF, you have to remember, you have to pull out something. So what do we pull out in this case? A 1. And I would have x plus 2 left over. So now if I factor this, I have pull out my common binomial factor, and I have 3x left over, and I have 1 left over. Am I done? No. Once I factor this, now I have to set each factor equal to 0. X plus 2 equals 0. 3x plus 1 equals 0. So x equals negative 2. There's one answer. If I subtract 1, 3x equals negative 1. When I divide by 3, x equals negative 1/3. That is my other solution. So if you know how to factor, this method of solving quadratics is not difficult, but you have to know how to factor. All right, please try the following problems on your own. Thank you.